Welcome to the 10th video of VCAA Specialist Math 2022 exam papers. In this video, we will present exam paper 2, section B, question 3, which consists of 5 parts. Part A was generally well responded to. However, errors involving fractions in the initial integration were apparent. Few students gave a correct response in section 1 of part B, and a significant number of responses lacked the required precision in section 2 of part B. Most students gave a correct response in part C and part D. About half of the students scored well in part E. Welcome to this VCAA Specialist Math exam paper series. This is section B of 2022 exam 2 paper. There are total 6 extended response questions in section B. In this video, we will present the third extended response question, in which it states that a particle moves in a straight line so that its distance x meters from a fixed origin O after time t seconds is given by the differential equation dx by dt equals 2 times e to the negative x over the sum of 1 plus 4t squared, where x equals 0 when t equals 0. There are 5 parts in question 3. Part A has 2 sections. Section 1 is to express the differential equation in the form of integral of g of x with respect to x equal the integral of f of t with respect to t. Section 2 of part A is to show that x equals logarithm base e of the sum of arctangent of 2t and 1. Part B has 2 sections, and it is based on the graph of x equals logarithm base e of the sum of arctangent of 2t and 1 has a horizontal asymptote. Section 1 of part B is to write down the equation of this asymptote, and section 2 is to sketch the graph of x equals logarithm base e of the sum of arctangent of 2t and 1 and the horizontal asymptote on the provided axis. Using coordinates, plot and label the point where t equals 10. The axes of coordinates are provided to sketch the graph in section 2 of part A. Here, part C of this question is to find the speed of the particle when t equals 3. 2 seconds after the first particle passes through O, a second particle passes through O. Its distance x meters from O t seconds after the first particle passing through O is given by x equals logarithm base e of the sum of arctangent of 3t minus 6, or in parentheses, and 1. Part D of question 3 is to verify that the particles are at the same distance from O when t equals 6 seconds. Part E of this question is to find the ratio of the speed of the first particle to the speed of the second particle when particles are at the same distance from O. It requires us to get the answer as a over b in the simplest form, where both a and b are positive integers. Now let's come back to answer part A of this question. According to the given differential equation, dx by dt equals 2 times e to the negative x over the sum of 1 and 4t squared. We noticed that variables x and t are separable here. Hence, we have the equation, the integral of 1 over 2 times e to the x with respect to x equals the integral of the reciprocal of the sum of 1 and 4t squared with respect to t. In order to find the relationship between t and x required in section 2 of part A, we do entire differentiation on both sides of the equation. So it becomes 1 over 2 times e to the x equals arctangent of 2t, or over 2 plus c over 2. Hence, x equals logarithm base e of the sum of arctangent of 2t and c. Since x equals 0, t equals 0, 0 equals logarithm base e of the sum of arctangent of 0 plus c, which gives c equals 1. Therefore, the function x of t equals logarithm base e of the sum of arctangent of 2t and 1. Section 1 of Part B is to show the equation of the horizontal asymptotes, and we have just derived that x of t equals logarithm base e of the sum of arctangent of 2t and 1. According to the properties of arctangent function, arctangent of 2t is greater than or equal to 0, but less than pi over 2, which gives that x is greater than or equal to 0, but less than logarithm base e of the sum of pi over 2 and 1. Therefore, the horizontal asymptote x equals logarithm base e of the sum of pi over 2 and 1, which approximately equals 0.944. Section 2 of this question is to sketch the graph and the horizontal asymptote when t equals 10. So x of 10 equals logarithm base e of the sum of arctangent 2 times 10 and 1, which approximately equals 0.92. Hence, when t equals 10, the graph is sketched below along the equation of the horizontal asymptote. The question in Part C is to find the speed of the particle when t equals 3 seconds. Based on the displacement function x of t, the speed function can be found by differentiate x of t with respect to t. So v of t equals dx by dt, which equals 2 times the reciprocal of the product of arctangent of 2t plus 1, or in parentheses, and 1 plus 4t squared, or in parentheses. So when t equals 3 seconds, v of 3 can be calculated by substituting 3 for t, which approximately equals 0.02 meters per second. 2 seconds after the first particle passes through O, a second particle passes through O. Its distance, x equals logarithm base e of the sum of arctangent of 3t minus 6 and 1. Part D of this question is to verify that the particles are at the same distance from O when t equals 6 seconds. As for the first particle, x1 equals logarithm base e of the sum of arctangent of 2t plus 1. And for the second particle, x2 equals logarithm base e of the sum of arctangent of 3t minus 6, or in parentheses, and 1. So x1 of 6 equals logarithm base e of the sum of arctangent of 12 and 1. And x2 of 6 equals logarithm base e of the sum of arctangent of 12 and 1. Hence, x1 of 6 equals x2 of 6. Part E is to find the ratio of the speed of the first particle to the speed of the second particle when t equals 6 seconds. We need to work out the speed of both particles when t equals 6 seconds. Hence, v1 of t equals dx1 by dt, which equals the reciprocal of the sum of arctangent of 2t and 1 multiplies 2 over the sum of 1 plus 4t squared, which gives v1 of 6 equals the reciprocal of the sum of arctangent of 12 and 1 multiplies 2 over 145. Similarly, v2 of t equals dx2 by dt, which equals the reciprocal of the sum of arctangent of 3t minus 6, or in parentheses, and 1, multiplies 3 over the sum of 1 and 3t minus 6, or in parentheses, squared, which gives v2 of 6 equals the reciprocal of the sum of arctangent of 12 and 1 multiplies 3 over 145. Therefore, V1 of 6 over V2 of 6 equals 2 over 3.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.